Hi, everyone. Welcome to reInvent 2025. For those that are experiencing reInvent for the first time, you're in for an incredible week of learning and innovation. Quick show of hands, how many of you have experienced agentic AI solutions in your workplace or daily life? Okay, so that's about a third of the 150 so people that are in this room. And how many of you have wondered about the architecture or implementation behind those experiences? Okay, about 25%. The adoption of agentic AI has truly been remarkable. At AWS, we've been privileged to witness our customers across industries rapidly innovating these solutions to solve complex business challenges and create transformative customer experiences to solve complex business challenges. However, this accelerated pace has brought significant challenges, from architectural decisions to production implementation and industry-specific considerations. That's exactly why we've designed today's session. We'll share insights into how different industries are leveraging agentic AI, explore common architectural patterns, and provide guidance on how moving from pilot projects to production. We'll also examine how application development is evolving in the era of agentic AI. My name is Eric Espeseth. I lead the solution architect team for enterprise customers in the United States for customers that are new to AWS. I'm pleased to be joined on the stage by Akhil Melakunta, who's a senior solutions architect, Jay Vell, a senior SA leader, and Kalpana Mahesh, who is a agentic AI specialist leader. Let me quickly walk you through what we'll cover today. We'll start with an executive outlook on agentic AI focused on the healthcare vertical and several use cases where our healthcare customers are transforming the patient care experience. Then Akhil will dive into the agentic AI architecture guidance and provide examples of how customers in the retail and e-commerce vertical are leveraging agentic AI to transform the customer experience. Jay will follow by exploring the path to production with financial service-focused view. To close out the session, Kalpana will walk us through the innovations of the AI development lifecycle, focusing on how learn and adapting the processes and what's on the horizon in this space. A common question we get from our customers is, should I be replacing my agentic AI efforts, my Gen AI efforts with agentic AI? The short answer is no. We like to say that agentic AI is an evolution in the AI space in general. Gen AI and agentic AI are complementary technologies, and that's because they are different, they serve different purposes. As an AWS customer, think about how you either have used or consider using Gen AI for common use cases and summarize information, generate content or visualizations, conduct translations, or those sorts of things. All of those are still fantastic use cases for generative AI, and we still encourage our customers to use generative AI for those types of outcomes. Agentic AI is similar but different. The primary purpose of agentic AI applications is to complete specific tasks. We're talking about solving complex problems, similar to the ones that humans solve, particularly when the outcomes of those decisions are subjective and involve talking to large amounts of data from various systems. Now let's dive a bit deeper into the difference between generative AI and agentic AI in the healthcare space. Customers have been using generative AI for use cases like chatbots in patient experience and digital health. In this domain, chatbots provide self-service care triage with proactive communication and patient care guidance. They also generate patient-friendly reports and post-discharge care guidance. Similarly, in care management, generative AI has been effective in summarizing records for registries and analyzing patient-level and cohort-level records to identify risk. It has also proved valuable in segmenting patient populations for interventions. In medical research and education, generative AI has been instrumental in solving clinical trial patient matching, summarizing research publications, and providing self-service Q&A for medical reference documents. We have observed generative AI outcomes boosting research efforts by automating data cleansing and enabling cross-patient queries to identify clinical trial matches. This diagram illustrates how generative AI, powered by large language models or LLMs, integrate with various healthcare data sources to achieve these outcomes. Now let's see where agentic AI is being effective in healthcare. In intelligent patient experience, we're moving beyond basic chatbots to autonomous agents that actively coordinate across multiple systems, pulling data from EHR, lab results, image repositories, and scheduling systems to create truly personalized patient journeys without constant human intervention. For hospital staff productivity, multi-agent systems now autonomously manage the entire clinical workflows, intelligently allocating resources based on real-time conditions, and even predict staffing needs before the shortages impact care delivery, fundamentally reducing administrative burden on clinicians. In supply chain optimization, agents continually monitor inventory levels across facilities, predict demand patterns using historical and contextual data, and autonomously trigger procurement workflows when needed, eliminating manual oversight of routine supply management. What makes this truly transformative is the agent orchestration layer shown in the middle. Unlike traditional Gen AI that makes recommendations in a single domain requiring human approval, these agents work together across multiple domains, making autonomous decisions and executing actions in real time. This orchestration layer enables the shift from reactive to proactive healthcare operations, fundamentally changing how healthcare systems function. Looking at these diverse industries, we can see a landscape rich with untapped potential. Each sector presents unique challenges that this agentic technology is uniquely positioned to address. The opportunities extend far beyond what we will discuss today. Executives are already having their teams working on these outcomes for various industries. What's particularly exciting is how these solutions can be tailored to industry-specific needs and use cases while leveraging common technological foundations. The most innovative organizations are already exploring these frontiers, creating competitive advantages through novel applications. The question isn't whether these opportunities exist, but rather which organizations will move quickly to capture them and define the next generation of industry solutions. While these opportunities are compelling, successful implementation isn't guaranteed. As we can see here, Gartner projects that over 40% of agentic AI projects will fail by 2027 due to escalating cost, unclear business value, or inadequate risk controls. This is precisely why the rest of this session we have focused on taking a strategic approach, keeping the value model at the center, and offering available solutions on AWS to achieve agentic outcomes at enterprise scale. And what is our vision for agentic AI on AWS? AWS's vision is to be the best place to build and deploy the world's most trusted and useful agents, enabling organizations to reimagine their business with agentic AI. We at AWS are working with customers to transform these ideas into agents, complexity into autonomy, and effort into outcomes, empowering organizations to deploy secure, reliable agentic AI at scale. Now, Akhil will walk you through the architectural guidance to build complete agentic AI solutions with retail and consumer packaged goods industry focus.
Thank you, Eric. Great insights. To understand a well-rounded architectural guidance when you're building agentic solutions, it is important to start off by understanding what it takes for an agent to be functioning, different approaches to use agents for different use cases, and what are the common patterns when you try to combine multiple agents to accomplish a task for you. So let's get started. So the next part of this session, I'll be using retail and e-commerce CPG as an industry example to share my point of view on architectural guidance, so you can understand to help technical aspects to your real-world examples. And most of the examples and the aspects that we talk here, you can go back and even map it to your respective industries as well. So what makes an agent function? What are the basic functions for agent to be performing at uh, to be performant, right? So at the core of it, agent uses an LLM for reasoning. To start off, when you design an agent, it is important to set a goal for an agent. An example for a goal can be this agent is a customer service agent supposed to solve a query within 2 minutes with an average customer satisfaction rate of 4.5. That can be a goal for you to start off. It is also important for agents to have access to tools. MCP servers are best example, so you can extend capabilities of your agents. Memory is also very critical for accuracy and performance. You want your both short-term and long-term memory accessible to your agents, so your agents can both store recent conversations and also results achieved for faster performance and accuracy. And at enterprise scale, it is critical for your agents to be able to access your enterprise data, so you can have your agents solve problems that are very specific to your business. Unlike any software system, it is important for agent to have an end-to-end observability and guardrails built on it, so you're continuously monitoring the performance and how agents are operating for your business. So now let's take a look at how, and with a basic agent, can help solve a problem in a retail space. So let's say a retail e-commerce customer is trying to build a purchase system where they're trying to address a user input, and this user has to ask a question about a specific product, which most likely means they're trying to purchase it. Can one agent that we just spoke about with all the basic agentic functions solve this problem? Definitely yes. But is it performant enough that you're tasking single agent to do all the work? In this case, you would want to look up who the customer is. Do you have that product in the inventory? What is the nearest store to purchase? These are multiple steps from a single prompt that you're expecting the agent to solve. Does it make sense for one agent to do it, or a series of agents helping this one single agent to do it in parallel, right? It's just more performant. You want that agent to go look up the customer, authenticate them, look up your inventory, whether if you have that product, do you have any promotion going on for the same user? Or, and then what is the nearest store that they can go and purchase? When all of these agents are in action, a well-rounded response would look like this. You have authenticated who the user is, given them a recommendation, some promotion that is very specific to that user, and then a nearest store for a better experience. So that is the pattern that we have seen customers using agents so far. More reactive in nature. People doesn't like chatbots so much anymore. But we have seen a foundational shift in how the customers are using agents now. They're moved on from reactive agents to more proactive and autonomous agents. So autonomous or proactive agents act on their own, doesn't wait for an user input like a reactive agent. So pricing is the best example to understand autonomous agents, because if you're trying to dynamically price products for your platform, it would make sense for your agent to act autonomously, right? But still, if you're from a retail space, pricing is not as simple as one agent can do this task. Oftentimes, our customers have teams of people accomplishing pricing challenges. So this is usually a team that would bring a pricing strategy to a platform. Now, to understand multi-agent collaboration, what if we solve this problem using multiple agents coming together, right? So before we get into understanding multi-agent collaboration, let's start with a basic understanding of how agents communicate with each other. So for agents to communicate with each other, agents use what's called an agent-to-agent protocol. It is an open standard protocol for agents to create an abstract layer when they communicate with each other, right? So this protocol solves the basic problem of interoperability between agents. So no matter what framework you develop an agent, another team within your organization, another agent can talk to it without understanding what is actually happening within your agent. So this protocol actually facilitates transport agnostic communication. So whether it is a HTTP with a JSON RPC sample request, or for a gRPC request for high performance use cases, or a simple REST method for web applications, you can use this protocol to communicate between agents. So now let's understand, going back to the pricing platform challenge, right? So my pricing platform challenge I have my market intelligence team. So I would want to design my market intelligence team with an orchestrator agent that sits on the top that can use multiple agents who are specialists in their own domain. So for my market intelligence, I want another agent acting as a competitor price scraper, going out and looking up for competitor prices and helping my orchestrator agent. So in this case, if I'm trying to price a specific product, I want my orchestrator agent to use multiple other agents that specialize in their own task and call them as a callable functions, almost use them as tools. So in this pattern of using other agents as tools is called agents as tools. It's a common pattern that we see customers use. Now let's look at how would you want to dynamically price your customers. So I want my agents for this specific use case to be able to segment my customers based on their history of number of purchases that they have made. So if somebody made more than 1,000 units, I want that customer to be segmented in a way that request is routed to a volume discount agent. So where the nodes of the agents are deciding the path of the communication between agents, this pattern is called dynamic customer pricing. So if you have a use case that would require your agent nodes to decide how you want to communicate between your agents, this pattern is better suited for you. Now about actually approving those prices that you have determined with the analysis so far. So when we strategize approving changes, I would want my agents to act like peers. I want them sharing a common knowledge base. I want them sharing a common memory where they're making their decisions based off it and sharing those decisions back to the other agent as well. In this case, all the agents here are sharing a common memory, and they're sharing their decisions back into that space and acting as peers, not making a decision in a hierarchical fashion. Now with that changes being approved with this flow, how would I push those changes into my platform? Pushing changes into platform is more deterministic in nature. I would have my base cost agent determine what is the base cost of a product. Now with all the analysis that we have drawn from all the analysis with all the other agents, I would have my market position of how I want to price that product. Now once that is done, I would want to apply those rules to actually push those changes and validate them before I do that. This is very deterministic in nature, where one agent is operating, getting an output, and sending that as an input to the second agent. So for any use cases where you have a very deterministic workflow, you can use what's called a workflow pattern. Return order management is another best example in this space, where the workflows are very pretty defined of what happens in a sequential fashion, and workflow pattern better suits in those use cases. Now let's bring everything together, right? So we have these multiple teams using different patterns together, solving a complex problem for an autonomous proactive agent to strategically price items for a retail customer. Here is the critical insight. These patterns are not mutually exclusive, right? In real world, when we work with customers, oftentimes it is a composite architecture that our customers adopt. Even in this specific case, I can have my dynamic pricing agent flow use a graph pattern, but even within that, I can have each individual agent calling other agents as tools. So it is oftentimes a composite architecture that will work for you. So you have to come up with an architecture that better suits your business case. Most customers with that level of architectural guidance will get to a very successful pilots, right? So pilots, when they try to move to production, a whole new set of challenges starts to arise. So Jay is now going to take us into his next section, where he'll walk us through his view on path to production and how you can accelerate it. Jay?
Thank you, Akhil. Welcome. Path to production. We're going to cover a couple of things as part of the path to production. Where to start, business value model, production challenges, some of the guardrails to avoid those production challenges, and some of the metrics to do the evaluation of your production workload. That said, I am Jayvel. This is path to production. You all see this pattern that's happening now. We all are talking about different vertical. Here I'm talking about finance vertical. Raise your hands if you're from the finance vertical or something to do with finance. Amazing, around 20% of the population? Awesome, good. And the 40% stat. Again, this is something from Gartner. Gartner predicts by 2027, 40% of the financial institutions going to use AI agents to automate their workflows. So that's it. Let's see where to start and when to start. Start right now and where to start. It's always good to start with a business problem. Talk with your business owners, line up business owners, and ask them what's the business problem they have. And then from there onwards, work backwards to meet that business need and build a pilot, and then you can move into production. We talk about the business value. Let's see how to build a business value or value model. And I'm going to walk you through a framework here. In the end, you can take a screenshot. Again, here, I'm going to talk about some of the cost elements, also some of the returns. And then we can see the ROI. Then we can take this to a CFO or any other line of business owners and get their sponsorship. So when you build any agent, first of all, the first cost is coming from the model API access. Akhil clearly explained you, like even for any agent to run, you need to have the LLM, large language model behind it. To access that, there'll be a cost involved. It's 25%. The next cost is model optimization. Imagine you're running the model, you get some good output. Now you want to fine tune the model, and then now you want to do more work. So that's where this cost comes from. Another one, where to run these models? You need infrastructure. That's where this cost is coming from. The next one, this is very important, data strategy. What is the key difference between an agent versus Gen AI, Agentic AI agent versus Gen AI? You can use your own data with agents. And again, how to use your data, where the data exists, and what transformation you need to do. All these things come as part of this data strategy. Next one is talent/development. Again here, your development team / how to coach them and upskill them. All these things come as part of this cost. Last but not least, operations and support and ethical AI. Again, in the financial industry, GDPR, or in the healthcare, HIPAA, all this comes together, how to build those governance patterns as part of this model. And that's going to cost you. So this is some of the cost model. But then let's dive into the return or revenue part. Again, there's some direct and indirect revenue. The direct revenues could be, think about, you have some agents, you charge each agent. Whenever you access, you charge per access. That's one way of charging or getting some revenue back. The another one is, you may also have the subscription model, like, for a month, we are going to charge this much. That's another way of getting direct revenue from agents. There are some indirect revenue. Like for an example, if the sales revenue goes up because of these agents, that's called indirect revenue. Then, on top of all these things, there are some returns that you may not put a dollar quantity on top of it, but they're very valuable. For an example, enhanced customer experience. Imagine you put a bot on your website and customers go there and ask a question. They get a really solid response. Now customers love your app. Right there, you increase the customer experience. Another one is boost employee productivity, or especially think about like a call center agent, actual human being, they have an AI agent next to them, and they ask a question, and they understand the person calling is what they need and what they had in the past, so now they can make a really good recommendation. That's how we boost the employee productivity, right? So all these come under returns. Now, what's going to happen? We have this cost and the returns. Now we can find the ROI, create a business case, and propose that to our CFO or other business owners, so we can get the business sponsorship. So now I'm going to walk you through a sample use case. Again, this may vary customers to customers, but I am giving a sample example what we observed in the past. For any given scenario, we have some assumption. I'm picking up an example from the finance vertical, like an investment advisory agent. For that agent, imagine you have 10,000 queries per day. This is for both human agent and bots. In that, we have 50% of the volume being handled by bots. Now, imagine the human cost is, I'm just putting a number here, $30 per hour, but then bots, obviously it's cheap, 10 cents per query. If that's the case, what's the ROI? The ROI is 10.8 million annual savings plus some new trades. What that means? As we use these agents, you can scale out and scale in so that there will be some new trades. Plus, there will be some cost reduction. You can see that obviously AI agent cost is very low, so there will be some cost reduction. Plus some customer experience. Think about it, again, bots or even customers are directly talking with the agents, they'll get some better experience, so your CSAT score goes up. plus new customer conversion also goes up. Finally, employee productivity. Like again, this could be coming from call center agents or even developers. If you put some tools with your developers, when they write a code, their productivity can go up. Plus, you can also give the employees or the human beings some complex tasks. Agent can do the mundane tasks. So this is a sample business model we build, right? So imagine you build this business model, and with Akhil's guidance, we build a nice pilot. So what is next? We need to move to production. So before we get into the actual production, I want to walk you through some of the challenges that we face in actual production itself. So you have the pilot ready. What's the first challenge, especially in the finance industry? Performance. We have millions of transactions and we need them in millisecond time frame. How do we get that? That's the biggest challenge. What's the next one? Scalability. Between 8 to 5, especially in the trading floor, agent should go up, and in the evenings, it can come down. How to build that? Next one, security. Each and every agent may have its own security, but then how to establish a security between those agents? Underlying data, all these come under another challenge. Another one is context. This is very important, especially in the agentic workflow, right? One agent may have some context. It may need to understand, and then when customer talk with the agent, they may give some basic context, but they don't have complete information about the customer. But then how do you go and find other information so you can give a customer a concise response? That's the biggest challenge. And then this is another important part, governance. Again, we talk about all these GDPR, HIPAA, all these things, how to build a concise governance model across all the agents. So these are some of the biggest challenges we face across agentic AI applications. But then, in the agentic AI agents world, there are some specific challenge. That's called agent silos. Raise your hands if you heard about agent silos. Wow, around 5-10%, that's awesome. So I'm going to explain you what is agent silos first, but then we can get into the agent silos, some of the challenges. So again, if you think about the financial trading floor, right? There'll be a market analysis agent. There could be a trading execution agent. There could be a risk management agent. And there's the actual human agent sitting there, or human trader sitting there. They're going to use all these individual agents to get some information so we can finish the actual trade, right? So with market analysis agent, imagine I'm the trader. I'm going to ask market analysis agent, hey, find this specific share. How is the social media is talking about them? Can I buy this or not? We get the whole sentiment from them. But then we go and ask the trading execution agent, hey, I want to get this share at this price, this volume. This agent is going to execute that. And then I'm going to go to the risk management agent. Imagine Eric come and ask, buy all these shares, and Eric wants to have this specific risk score that he wants to manage. If that's the case, I'll specify that one and find the right mix of the shares, right? So the key here is each and every agent is doing its own job and writing the data using their own services and writing in their own location. It's fine for the timing because I am the human agent doing all this work. They don't need to talk with each other. Let's go to a little bit more complex situation. Now, we get a really good output. People are happy. Build more agents. Guess what? I'm going to put some portfolio management agent, strategy agent, then risk management, also communication agent. Guess what? The communication agent need to talk with other agents to get some information so they can talk with the end customer. This is where a challenge comes. If you have these individual agents, write the data, access their own services, write in their own locations, now they cannot talk with each other. This is what called agent silos. Think about it. That said, let's see what are the challenges of agent silos. Like I mentioned earlier, one other thing is integration. Market analysis agent and strategy agents need to talk with communication agent. So it can be communicated to the end customer. That's where the integration comes in. Another one is security. When Akhil's team builds its own agent, they use some specific security services. When Jay uses, he uses some specific services, right? Now, how do you build a comprehensive security patch across all the agents so they all can use the same services and build a governance pattern? That's one of the biggest challenge. The next one is data inconsistency. This is again comes like, one agent writing into one location, other one writing into another location. Now, they both may have similar data, but different time frames. Now, that's where the data inconsistency comes in. Another one is scaling. Again, like I mentioned earlier, again, this scaling, you can think of kind of like inefficient scaling. What's going to happen is you ask this communication agent to do some work, and then there's a risk management, there's a market analysis agent, they all are doing some work, but they're not sharing any data among them. So they're going to scale in their own, they're going to use all the services, whatever they want, they're not using anything across each other, so they're inefficiently scaling, which is not good either. So that said, let's see how can we overcome all these challenges. So again, this is a sample of production application. Again, in the end, you can take a screenshot of this application, how it looks like. So if you think about any agentic application, we first start with a top level or application layer level, where we are going to have a web and mobile app, where you can access the agents. Also, you might use some IDEs like Kiro. I love Kiro, by the way. So it'll help you to develop the applications very fast. And then there might be some chat interfaces. It's getting more and more popular nowadays. If you want to talk with agents, chat interfaces is another cool way to access agents. So what we should do first, we need to authenticate. So to authenticate with agents, we can use Amazon Cognito, a great service, or you can use any of the authentication services. Once you authenticate with the agents, the next thing is we have agents and MCP services. You might heard about MCP services, but again, it's kind of like a services that use a protocol that you can access outside tools / data sources with agents. That's what MCP services are. And then underneath that, LLM comes in, large language model. Again, you can use any large language models recommended by Amazon, AWS. I mean, talk with your solutions architects. They will tell you a list of all the LLMs that you can use. Again, to access those LLMs, AWS, Amazon offers our Bedrock. It's an API service. You can access any of those LLMs. Once you access those LLMs and build your POC or pilot, what is next? Move into production. That's where Agent Core comes in. If you want to deploy your agents in scale, you can use Agent Core. Not only that, there are so many other advantages. I'm going to walk through them while I'm opening other slides. So what is the next layer? Semantic layer. What is this? Imagine you have your LLM ready, and you wanted to use your own data. You cannot just use your data as it is. You may need to do some data manipulation, some ETL job. Plus, you may need to create some new connectivity between those data. So agents can use them as it is. That's where the semantic layer comes in. You can use services such as AWS Glue. It'll do some ETL work for you, or Amazon Neptune database to create some graph or connectivity between the data. That's where the semantic layer comes in. So what is next? Guess what? Data. Again, under the hood, everything driven by data. You might think, oh, we need a data lake immediately. Guess what? No, you don't need a data lake for this one. Obviously, you can say, if you have a data lake, amazing, you can use it. Even if you don't have it, still, if you know what is your data, where it is, and how do you need to transform that to use your agents, that's enough. So have a comprehensive list of all the data sources and all these changes, and with that, you should be able to build your agents and move forward. So once you have all those things done, your application is ready. Now you want to observe across all the layers. And again, Agent Core offers functionality. You can observe not only across different layers, but also inside your layer. Imagine your market analysis agent wants to talk with communication agent, and what's happening between those two, you can observe it using the observability framework that's offered by Agent Core. After all, security is one of the top priority for Amazon AWS. So guess what we could do? When your customers make a call, imagine if Kalpana is making a call to buy, say, 100 shares from AWS, Amazon, right? If that's the case, what's going to happen? Kalpana gets a dedicated session-level security for her session, which means there won't be any data leak. Any data leak, that's offered by Agent Core again. So that said, we talk about the production workload. Now we are going to talk about some of the evaluation techniques / some metrics. Last year, if I ask you, hey, how many evaluation metrics do you have? You might say 5 or 6. This year we have 20. Next year, who knows? It might be 100. The reason I'm telling you is all these are not like, there'll be a lot of metrics here. But for your vertical, it varies. And also, you may have your own custom metrics as well. But especially for the finance, I'm going to talk about 3 important metrics here. 1, accuracy. When you make a transaction with the bot, hey, I want to buy this many shares, this price point, it should be that. We cannot change that. So that's where the accuracy comes in. The second one is robustness. What does that mean? When you train your model, you use your training data, models behave just fine. But when you move to production, we have some real-world data there. But still, model needs to behave the same way. That's where the robustness. The last one, this is one of my favorite things, tone. So what does tone means? Like if you think about any bots that you interact right away, like if you can think about like it's a bot voice and all those things, you will never get trust from that voice. But when you build a financial advising agent, it should have a voice, not only just convincing, but also data-driven. How do you build that? That's the end of the matrix that we use. So that said, I talked about where to start, also how to build a business value, what are the different evaluation techniques, production workload, all those things. But now I'm going to hand over to Kalpana. She's going to talk about some of the cool innovations, she has new development life cycle. So that's it. Kalpana, floor is yours.
Thank you, Jay. Hi, everybody. How many of you have done something today for Cyber Monday shopping on Amazon.com? Only one person. Oh, a couple of people. Okay, awesome. So, we've been talking about agents across multiple industries, healthcare, retail, and financial services. Now, let's make it super personal and real. How many of you are aware of Rufus, which is an agent that sits on Amazon.com? A few people. Okay, I use Rufus all the time, and it's super helpful for me as an agent. And now I have Rufus even watching prices for items that I really care about and alerting me when it hits the right price that I want to buy it at. So it's a very proactive agent for me that watches Amazon.com on my behalf and does actions. Now, how much do you think Jay talked about, if I had an agent that's a bot that's helping my customers, it could enhance the customer experience by 15%. How much more likely do you think people are to buy a product if they engage with Rufus? Just throw out some numbers. What percentage do you think people are more likely to buy a product once they've engaged with Rufus versus not engaging with Rufus? Throw some numbers. 80%? It's 60%, 60% more likely. So if you've engaged with Rufus, you're 60% more likely to actually complete the transaction versus if you haven't engaged with Rufus. And it's projected to make a $10 billion impact, incremental impact on .com for us. So having Rufus as an agent and people engaging with Rufus is going to bring in projected additional $10 billion with a B. So that's how powerful agents can be in real life if they are doing all of the things that my colleagues talked about. They have the right voice, they're secure, have the right tone, are able to give you accurate answers, are performant and scale. I mean, it does us no good if Rufus comes back in 5 minutes and tells me something. I moved on to something else, right? It needs to be performant. It needs to scale. Hundreds of thousands of requests every second, and Rufus needs to scale across all of them, but in a very secure way. So we've talked about multiple industry use cases. What is top of mind for execs across all of these industries? It's not specific to a certain industry. You know that executives across all these industries are very concerned about speed of innovation. That's one of the things that's top of mind. But how do I innovate at scale and speed while keeping my ROI front and center? Because it has to still produce business value. If I did Rufus just because it's a cool toy, that's not going to go very far. I need Rufus to actually deliver business results like $10 billion of incremental revenue for it to make sense for me to invest and do all the performance and the scaling and the security and the governance, right? But innovating at speed while delivering business value is top of mind across all industries for executives. At the same time, how do I get my people educated? And if agents are going to be my teammates, not just tools in my organization, how do I integrate agents into the organization? What will that org design look like, right? That's, again, top of mind for executives at all industries. Processes. Jay talked about responsible AI, and Akhil talked about the architectures that you can develop for a very secure, responsible agentic system. And security and trust as a technology platform across all layers of your agentic development, whatever your architecture that you're building. It's extremely important. So these are some of the key areas executives are very much concerned about and bringing agents to production in a very responsible way. Across all of these concerns and all of these use cases, we talked about speed of innovation, right? So how do we transform traditional development approaches using agents to build agents, right? So that's the key here. How do I take advantage of agentic AI to put my net new agentic innovations into production, regardless of any industry? And how do I reimagine that development lifecycle? Not just make incremental progress, but how do I transform and reimagine the whole thing? And that is what we're talking about in terms of future of software development. We're all very familiar with traditional programming with software development lifecycle, SDLC. They're very familiar with that. But in a very short 3-4 year time span, traditional programming has been dramatically disrupted, where we've gone from code completion to chat-based programming. Everybody's doing vibe coding now, but in the future, we anticipate AI clusters and AI fleets to be helping our development teams. Now, what you see on the right-hand side is a very hierarchical imagination of agents coming into and becoming teammates on your dev teams. But really, what will happen in reality is more a swarm, a very decentralized agentic groups of things that are happening along with human collaboration to bring something to forth. That's really what we envision. But the reason it's shown as hierarchical is to get conversation going. When people see org design with agents in it, it gets a conversation started. And executives are like, how do I think about agents in my organization? What do I do about KPIs for those agents? Do I measure them just like humans do? And what do I do with comparison? And how do I account for ROI? What's my cost going to be? What should the value that I should derive from them? They all have calculations for teammates, right? How do I do the same things for agents? It's a great conversation starter, but it gets people thinking. So AI DLC is the same thing as SDLC, but doing it with AI in every way possible. How do I get agents and AI injected into my development lifecycle to build my net new innovation is what AI DLC is all about. It's a methodology, not necessarily a product or a service. So regardless of what service, what tool, what product you're using, you can always adopt this AI DLC methodology to help speed up your innovation. Again, goes to speed of innovation and doing it at the right cost. And bringing agents into your development lifecycle for your net new product. It could be a net new software product you're building. It could be a workflow that you're trying to automate that helps with employee productivity within your organization. It could be a customer service agent that you're putting in place. It doesn't matter what you're trying to do. But if you bring in an AI methodology, AI development lifecycle methodology to it, you are going to automatically speed up your innovation. And that's the fundamental thing that we're trying to do with AI DLC. And there are 3 phases to AI DLC. The first phase is inception. This is where you're kind of thinking through what the product is going to be. How am I going to develop the product? That's the fundamental thing of in inception. And then construction is when we are going to get into active construction. This is where you're building your net new innovation. And then operations is you have to deploy it at scale and get it productive, right? So let's look at how this works and what the roles and rituals are. How many of you are familiar with agile development in your firms? Majority of you are very familiar with agile development. So you understand what roles and rituals are. So how do we take those roles and rituals that you're very familiar with SDLC, and how do we change it and alter it for AI DLC is what we're going to look at. So remember we talked about the inception phase. This is where you have this large intent that you're going to go after. Maybe you're building a net new product, a net new project, whatever you're trying to do. So what is the intent of that? And then you want to break it down, in the old style, we would call it epics, right? Here we're going to break it down into units. And how do we do that? That's the key thing with AI DLC. It's not just, I just changed the word from epic to unit. That's not what it is. It really is, how do I use AI in my inception phase? So I am not the one writing the units. I have the large intent, and I am going to get agents and AI to write the units for me. What is the task to be performed? What are the features that I need? And you prompt the agent to give you those answers. So AI is actually doing your units for you. It is not a human doing it. So what's the role of the human? What's the product owner? What's the development team doing with AI in inception? They are guiding it. They are reviewing it. So that's how you get the speed. The next phase is actual construction and development. Here you're doing mob programming and mob testing. Again, the development team is not actually writing the code. They're prompting AI to write the code. And that's the key here. So your job is to prompt, review, redirect, prompt, review, redirect. And so you go in that loop. And you will see that we're not doing sprints anymore, we're doing bolts. Why? It is really specifically conveying speed of development. Sprint as fast as you can sprint. If you're Usain Bolt, you're really bolting, right? You're not sprinting. So that wasn't meant for Usain Bolt, but I'm just making some correlation for it to stick. So you really are at lightning speed moving forward with your development and your testing. And it's an iterative loop. You can see how each bolt goes into a loop where you've got the code, you prompted, it's given you code. Agent is going to get you the test units as well. AI is writing the test cases. It's testing, confirming, and then we're going in that loop again, right? So you get through development, and then you're going to go do deployment, where product owners, developers, and AI are again involved. But again, for deployment, infrastructure as code, AI, agents helping you deploy what you have produced as well, what you've developed. So that is what AI DLC is, where the primary focus is not humans doing the tasks, but how are they going to get AI to do the tasks, and how are they prompting, reviewing, redirecting, and going in that loop. That's the key. And what can you really achieve by using AI DLC versus SDLC? That's a good question, right? Here's a customer, Dan, who took their existing Jira backlog, whatever that they have in Jira, and used AI DLC against their Jira backlog. So this is not for a cutesy, net new, brand new development only project. AI DLC is not only for, oh, what's a net new idea? I have no tech debt. I am starting from a blank sheet of paper, and then I will deploy AI DLC. It's great. It will work for that as well, but we know the reality in most enterprises, we already have running projects right now that we want to speed up, net new projects we want to add, features we want to add to existing products. That's the reality of life. So the question is, can I use AI DLC for those? Absolutely, you can use AI DLC for it. It's a methodology that we come and teach your dev teams on how to do, where we walk the product owners, the dev teams, and the test teams on how to use AI DLC, adopt it as a methodology, using your existing tools, existing services, existing backlog that you have. Just using this methodology, how can you speed up? And with Don, we were able to take what was 2 months of development using their existing agile methodology that they had put in place, and we showed with AI DLC how they can deliver it in 2 days instead. So that's the kind of revolutionary reimagining transformation we're talking about. It's not incremental. It's not going from 2 months to maybe I could cut a week off. It truly is taking 2 months of your existing backlog and how do I deliver it in 2 days. And that's what this methodology teaches you. So in closing, right, we have seen multiple industry use cases across healthcare, retail, finance. We have seen what are the key architecture patterns that you want to adopt depending on what you want that agent to do and how you use an orchestration layer to bring all these agents together, where you're using multiple architecture patterns for the individual agents, but then working as a team, how do you bring that together? We talked about how to go from pilot to production and what are the key things you have to keep in mind, and then what is a methodology you can use to speed everything up, get your innovation faster, and get to your ROI faster. Hope that was very helpful. We have a few minutes left. We can take some questions if you have any.